want to introduce the concept of a confidence interval. To do this, I'll start with 4 key concepts. The first one, of course, we've already seen is the idea of a sample size. That's the number of observations that one takes from the population. The second thing we'll be looking at is something called a confidence level. And we'll be looking at something called a margin of error, which is used in common speech, meaning to say the tolerance level or something like that. And finally, we'll be talking about a confidence interval. I'm going to come back to each one of these terms and make them explicit. With the sample size, one knows already. Okay. So, and I'm going to use 4 examples. Let's call the examples A, B, C, and D. Let's start with example A. Example A, I'm going to call this the 78% example. Let's say, for example, I stop in the cafeteria and choose 6 students at random. It's going to be a simple random sample. Now, we know that the R-score is designed by the Ministry of Education to have a population mean of 25 and a standard deviation of 5. It's set up that way. So I would expect that if I chose 6 students randomly and calculated the average of these 6 students, I would expect that the average of the 6 to be pretty close to 25. Maybe not exactly 25, but, well, how close? Well, how could we figure this out? Well, the first thing would be to determine the standard error. Keep in mind that n is equal to 6. I know that this population standard deviation is 5, so we could figure out that the standard error, I've done a calculation, is 2.041. So then, if I were to say what is the chance that the average of these 6 students is above, say, 27.5, this gray area on the side there, well, what would you do? Well, you'd use that normal app, click on it, and we'd have to change the spread here to, what is it, 2.041. I can do that here. And then I'd say it's got to be 27.5, so I'll change this to 27.5. This is arbitrary, by the way, the 27.5. And, whoops, got that wrong somehow. There we go. And the answer is 11%. See if I got that right. Yeah, it's 11%. So now what would be the chance that the average of the 6 students, the average R-score of the 6 students, is lower than 22.5? Well, we know that the normal curve is symmetrical, so it's going to be the same on the left-hand side. That's going to be 11% as well. Which means, too, that we could say that if I stop 6 students at random, calculate their average, we would expect that the mean of the average of the students should fall somewhere between 22.5 and 27.5. About a 78% chance of that happening. There, of course, be like a 22% chance that it's a higher than 27.5 or lower than 22.5. Now, based on this, we can now present the 4 concepts. Well, actually, there's only 3 concepts. We're going to do them again and go through them each one. First one is the sample size. Well, that's 6 students that I stopped. Random choice. Second, the level of confidence. That's the 78%, and I'm going to refer to that as 1 minus alpha, but we'll just call it 78%. That's the chance that the average of the 6 is going to fall between 2. Margin of error is the amount we added and subtracted. In this case, I just added 2.5 to get 27.5, and I subtracted the same amount to get the 22.5. We can also refer to this as a confidence interval. It happened to be the lower bound was 22.5, completely arbitrary, I just chose it, and 27.5. What that means is the margin of error and the confidence interval are in effect the same thing. Margin of error is what you add and subtract from the mean, and the confidence interval, well, is the region itself, 22.5 and 27.5. A little point here. We've already seen this idea of alpha, which is the significant level for a test, exactly the same thing as the confidence level. In effect, the confidence level is 1 minus alpha. So alpha represents the area outside, which in our case before was 22%. Little note, too, about brace and brace, for example, they use capital E for the margin of error. I'm going to keep using ME because it just makes it a bit clearer. E might be something else. So let's try another example, example B. In this case, I'm going to set the margin of error equal to 3. If we changed it, then what? Well, what's going to happen now? Well, that means the amount we'd have to subtract or add or subtract from 25. So in this case, we've already set the upper bound, which is going to be 28, the lower bound, which is 22. And now I can write this as the confidence interval. Keep in mind, CI, the confidence is going to be 25 plus or minus 3.0. I can graph it this way. We still have the same standard error, so that's the spread. I'm going to have, well, previously I had 22.5 and 27.5. You can see that in this case, what's going to happen to the confidence level that was previously 78% inside here? Well, we know that this number is going to have to widen out. So you can expect that the confidence level is going to have to get bigger, probably. And what's going to happen to alpha, or alpha over 2? Alpha is the area outside. That was 22%. Well, that's going to get smaller, and alpha over 2 I would expect to get smaller. Let's take a look. Here we've got, same as before, I'm going to set the margin of error equal to 3.0, so I'm going to make it equal on both sides, 22 and 28. I figured this out. I did the normal app and found out that it's equal to 7.1% on both sides. That means the area inside is, the confidence level is now 85.8, which means that alpha is equal to 14.2% and alpha over 2 is 7.1 on each side. Let's try a third example now. Example C. This time I'm going to set the confidence level equal to 80%. So now we have to figure out what is the upper bound and the lower bound. Let's take a look at this. Once again, we've got the same standard error. Keep in mind n is equal to 6 in all these cases. And I'm going to set 80% being the center. That means I'm going to have 10% on the right-hand side, 10% on the left-hand side. 1 minus alpha is going to be 80%. Alpha over 2 is going to be 10%. This is going to be alpha over 2. This is equal to 1 minus alpha, which is the confidence level. Now, what is the upper bound and lower bound going to be? Well, once again, I can use that normal app to put in the 10%. And we know that this is going to have to get wider compared to the 78%. So we know that the upper bound and lower bound is going to be a little bit wider than we had before. I calculated, did it with the normal app, and you'll see that the upper bound is 27.62, and the lower bound is going to be 22.38 rather. So again, repeating what this means is that you'd expect, if you stop 6 students at random, calculated their R-score, the average of the R-scores, there's an 80% chance, 5 rather, that the average would fall somewhere between 27.62 and 22.38. We could write this as well as confidence is 25 plus or minus 2.62, which is the margin of error. Write it like this. The margin of error is equal to 2.62. And again, whether we do it with the upper bound and lower bound or whether we do it as a margin of error, it's the same idea. Let's try a final example, example D now. I'm going to change the sample size now. Let's say we've got 16 students instead of previously 6. What changes here? Well, now the standard error is going to change. I'm going to take 5 divided by the square root of 16, which is 1.25. So you'll notice that I'm going to shrink it in now. If I keep the confidence level at 80%, that means the area in between is still 80%. We've got 10% on either side as before. What is going to be the upper bound and what's going to be the lower bound? Well, once again, we can use that app, but you can quickly see that clearly this confidence interval is going to be narrower, right? Because now the spread is narrower. The standard error is smaller. I figured it out using that app. I got 26.6, 23.4, which we can write now as the lower bound and the upper bound. We say at an 80% chance. And see as well that this is the margin of error here is 1.6. It's gotten smaller compared to the example C a moment ago. And why? Because we've got a larger sample. The standard error is smaller. Once again, the concept of whether we talk about upper bound or lower bound or whether we talk about the margin of error, so the confidence interval, same concept. Good way to think about this is a bit like the game of tossing horseshoes. You know, people take the metal portion of the foot of a shoe, they toss it at a pole. Let's see what this means. Several horseshoes. We toss them, misses. Misses. This one hits the target, and this one misses. So we can sort of imagine it this way. The number of horseshoes that hit the target is the confidence level. That's like saying, in this case, it would be 25%. Previously, you had things like 80%. So it's like the chance that you're going to get the sample mean within the expected number. Top six students, calculate their average. We would expect it to be inside, a bit like hitting the target. The width of the horseshoe is a bit like the margin of error. So now you can sort of understand that if you make the width of the horseshoe larger, if it's wider, you're more likely to hit the target. If you make the width of the horseshoe narrower, then it's less likely to hit the target. The confidence level will go down. So we can now put these ideas together in preparation for the next lecture, is that the standard error reflects the sample size. That's kind of like the amount of information you've got. The confidence level, or sometimes referred to as the level of confidence, reflects the chance of hitting the target, if you will, and the margin of error reflects the width of the confidence interval. You can pick two of these, and the third one is predetermined. So have it clear in your mind that these three ideas go together, but only two are really possibly predetermined. The third is fixed.